So for the points A, B are coordinates -3, 0, 5, 0, respectively. Consider Apollonius' circle C, which is the locus of point P, where AP over BP equals K. So I like to take this circle, make it a little bit bigger, and we'll make it something like that. We'll draw a line there. We'll say that that's kind of a radius of it. And out here, I'll put -3, 0. Here, I'll put, well, the center is going to be 13, 0. And this one here is going to be like 5, 0. Give you a chance to write that down. And we're going to pick on a point P here, where if this is A and this is B, if you took AP, and this is at X comma Y, if you took AP over PB or BP, that's going to be equal to some constant K. Anywhere on this circle, including this spot right here. So far, so good? Okay, so this place here, we found there was some ratio that we figured out. Was it, if this is a C here, wasn't there an AC? Now I forgot it. Find it. As a formula, we're going to find R first. R squared is going to be something times something. And I need you to find that. Part of Apollonius's theorem is that if you took, I guess we call this thing here C, don't we? So we would say AC times BC is equal to R squared. So that was part of it. So AC is going to be 16, and what's BC going to be? 8. And that's going to be equal to R squared. So this is going to be 16 times 4 times 2. And if we take 16 times 4, what do you get? 64 times 2. So if I take the square root, I'm going to get 8 square root of 2 is the radius. So this is going to be R equal to 8 square root of 2. Now the x-intercepts will be very easy because how far is it from here to here? 8 square root of 2. So won't the intercepts be equal to 13 plus or minus 8 square root of 2? Those are the two x-intercepts. If you want to put them as 13 minus 8 square root of 2, comma 0, and 13 plus 8 square root of 2, you got those. What don't we know? K yet. But no problem. We can find K because we can take this point P anywhere on the circle. Where would be the easiest place to put it? On the line. So we're going to get, if this is X, Y, right? Wait, do I want to do that? No. I don't want to do that. This is 13 minus 8 square root of 2, comma 0, right? So let's do it. AP is going to be 13 minus 8 square root of 2 minus a negative 3. And what's BP going to be? 13 minus 8 square root of 2 minus what? 5. Just make this a little bit neater. This is 13 minus 8 square root of 2, comma 0. Okay, so all I did is I took this distance, this minus negative 3, and then I took this distance minus 5. So now when I do the algebra for this, you're going to be left with 13 plus 3 is 16 minus 8 square root of 2 over 13 minus 5 is 8 minus 8 square root of 2 is equal to k. So if you divide by top and bottom by 8, you'll get 2 minus the square root of 2 over 1 minus the square root of 2 is equal to k. Now imagine that you didn't have your calculator. How are we doing, Alex? With us? Okay. If you didn't have your calculator, how could you get rid of the square root of 2 in the denominator? By the, oh, you got it. You got it. What is it? What is it? Starts with a C. Ends in you get. There you go. 1 plus the square root of 2. 1 plus square root of 2 equal to k. So this is going to be, FOIL it out. 2 times 1 is 2. Negative square root of 2 plus 2 square root of 2 will be plus the square root of 2. But then it's minus the other 2 root of 2, which is minus 2. In the bottom, it's 1 times 1 is 1. Minus square root of 2 plus square root of 2 is 0. Minus 2. Is this going to work out? 2 minus 2. I get the square root of 2 over negative 1 is equal to k. K is going to be absolute value. So k is the square root of 2. Yeah. Yeah? Oh, I love it. Sure. Factor the negative square root of 2 here. Okay. Wonderful. We just get it right away. I never thought of that. And then now we're going to finish this one. The remaining 3 marks, it says let M be any point C and N be the x-intercept and C be between A and B. So that's what we had up here. Quiet, please. So what we're going to do is we're going to put C in the middle this time. Here's your C. And it says, prove that AMN, let M be any point on C, and N be the x-intercept. So what they're saying here is N is down here, and then M is up here. Okay? And we're going to make 2 triangles. We're going to make this triangle, and we're going to make this one. Let M be any point on there. Prove that AMN is equal, is that equal to, NMB. So we're going to prove that those are equal to each other. So what we probably need to do is to show that they're what first? If they're equal angles, probably have to show the triangles are similar. And we're going to do that right now. So using this relationship, AP over BP, what we can do is we can say, okay, with this value N here, that AN over BN, or NB, AN over NB, AN, NB, is equal to the square root of 2. Do you agree with that? And what will B, or AM, over MB be equal to? Also the square root of 2. So if we put those together, you're going to get AN is equal to the square root of 2. Well, actually, I'm done. So AN over NB is equal to AM over MB, since square root of 2 equals square root of 2. Therefore, what can you say about ANNB, AMMB, since sides are what? The triangles are similar. What is this showing? The sides are what to each other? Proportional. And then I would say triangle AMN is similar to triangle BMN. I want to make sure I write these. NMB. Perfect. And therefore, since triangles are similar, corresponding sides are what in a similar triangle? Sides. Corresponding angles, not sides. Angles, excuse me, are what? Equal. Yep. Then, what are the two angles we're looking at? AMN is equal to NMB. Angle AMN equals NMB. Love that one. If you look at this problem, we have, I'm going to use colors here, AP over PB is equal to QA over QC. Now what we're really trying to get at here is we're trying to see a similar triangle. This one is similar to the whole, which is this one. But we're not there yet, because these black segments are just the trapezoid part. We want the whole triangle. What I want to see at the end here is that triangle APQ is similar to ABC. That's what I want. And the way I'm going to get it is I'm going to add 1 to both sides, which is the equivalent to AP plus PB over PB, because this is 1. And this is equal to QA plus CQ, both of these over CQ. And now, what is AP plus PB? What is that length? What is length AP plus PB? AB. And what is AQ plus QC? QA plus CQ. What's that total length going to be? Yeah. So we're going to get AB over PB is equal to AC over CQ, or QC, I guess. And then what we would say is, since sides are proportional, then the triangles are similar. And if the triangles are similar, then what can we do? If this triangle is similar to this big triangle, can we say that this angle is equal to that angle? Okay, why would I want to do that? Because then they're parallel. You need to say that to make them parallel. So one more time, we did the sides proportional to make the triangles similar. Now, I'm going to go down, help me out, APQ, therefore, angle APQ is equal to angle, you can say ABC. Because corresponding angles of similar triangles are equal. And then lastly, therefore, PQ and BC are parallel. Therefore, PQ parallel to BC by definition of parallel lines. Right? Because they have to have equal angles, so therefore they're parallel. Now here's the part you're not going to like. But go ahead, turn to your neighbor real quick, explain that all the way through from top to bottom. You have 1 minute. I hear some rustlings in the back that we're half done. And you're right. Because you see the if and only if, that means we're half done. We have to show the converse. But when I looked at what the answers did, this is what they said. Statement of converse is reversible. Totally lame. I don't get it. I don't get how they can do that. They made it worth 2 marks. You have the mark. You need those because you need to say the reverse because it says if and only if. So don't forget to write it. But if you're stuck, I would just write that. But what they're saying is you could go in reverse of all these and get back to what you had at the beginning, which is not very satisfying.